This question is asked in GATE 2006. X, Y, Z are sets and their sizes are x comma y comma z. They have given a set called W and W is x cross y and E is the set of all subsets of W. That means this E is collection of all subsets of this W. Now we have to compute the number of functions from Z to E. Okay, so we know the size of Z, isn't it? Size of Z is small z and we don't know the size of E. Let's assume that is mod E. We know that, did you remember, when you have functions from set A to set B with size m here, size n here, then the total number of functions possible from here to here is n to the power of m, isn't it? Now the same question here. The question is the number of functions from Z to E. Let's say this is Z, this is E. Then according to the formula, it is E size of E power size of Z. That's why answer is size of E power size of Z. That's the formula for function. Now, what is size of E? For that you should read the definition of E. E is the set of all subsets of W. Okay, but I don't know what is W. W is x cross y. Since W is equal to x cross y, then it contains x into y elements, isn't it? Cartesian product contains xy elements. If x contains x elements, y contains y elements. We know that. Now E is the set of all the subsets of W. Since W contains xy elements, the number of subsets for W will be 2 to the power of xy. You remember it. There are 2 power xy subsets, right, for this W. So that's a definition. That's a definition of power set. Did you remember? If any set has n elements, the total number of subsets are 2 power n. Now you are collecting all that subsets into E. That's why size of E will become 2 power xy, isn't it? Since there are 2 power xy subsets and E is a collection of such subsets that contains 2 power xy elements. Let's directly substitute into the formula. So mod E equal to 2 power xy and whole power size of z, which is small z. That will become 2 power xyz. So option D is the right choice. Okay, let's see second question, which is asked in GATE 2006. You have a set S which contains m elements and m greater than 3. x1, x2, x3, so on xn are subsets of that set S. Okay, so whenever a problem is given with sets, my suggestion is always imagine it with some real world objects. Let's take all these elements as teachers. Okay, so if you assume this as teachers, then you can easily connect to the problem. S is m teachers, set of m teachers. They are numbered 1, 2, 3, so on m, where number of teachers are greater than 3. Now x1, x2, x3, so on xn be subsets. Subset will become committee. Okay, committees of S, each of size 3. In that way we can interpret problem in a different way. You have m teachers, you have all 3 size subsets which are committees, all 3 teacher committees of size 3. Now define a function f from teachers S to the set of natural numbers. That means they are forming a function from your teachers 1, 2, 3, so on to some natural numbers. Let's say natural numbers, right, like 1, 2, 3, so on infinite. How what's the functionality of this function, which is not given, but it is from S to n. Let's read further. F of I is the number of sets xj that contain the element I. So that means let's read it with f of 1. So f of 1 is the number of sets. Sets means here committees. Number of committees that contain the teacher I. That means teacher 1. So now easily you can understand that f of 1 is mapping 1 to the number of committees which contain teacher 1. Understand? In the same way f of 2, f of 3, so on. Now you see the question. Question here is sigma I equal to 1 to m f of I. That means we have to compute f of 1, f of 2, f of 3, so on for every teacher, and we have to add. Okay, that's a problem. But what about this one? F of I is given in a different way, like they have given a different description. We'll read it. This is called set form. We'll see that set form of f of I. F of 1, let's read f of 1. F of 1 equal to, this one, j. What is j? He is explaining here. Whenever your 1 belongs to some xj, it's a committee. Okay, whenever your teacher belongs to some committee, you are collecting that committee number. Okay, then you are forming here all such numbers. What is the significance of number? It's a committee number. Then you are collecting all the committee numbers, and after that we are applying mod function. That means it's a cardinality. So we are collecting all the committee numbers and we are finding the total number of such committees. That is, mod indicates total number of such, size, set. Mod indicates always size of the set, isn't it? What is this set? This set is collection of all the committees, and mod of that collection is nothing but size of such collection. So that is nothing but indirectly again the number of committees which contain your element I. Correct? Let's revise it. F of I equal to j whenever I belongs to xj. That means whenever your teacher I belongs to some committee, you collect that committee index. After collecting all that indices, you find out the size of such set. That means they are all, number of committees which contain I. That is what the concept. So he has explained it in two ways, here and here. So if you understand in one way, that's okay, right? Let's go to the problem now. How to solve it? If you compute f of 1 value, then automatically we can compute f of 2, f of 3, so on. The reason, everything is same, because in the problem these are all, I can say that symmetric values. That means there is no significance for a particular number, right? Anything you can take. So whatever the value f of 1 gets, same thing f of 2 gets, same thing f of 3 gets, so on. That's why only I calculate f of 1 first. Let's read f of 1 clearly. F of 1 is number of committees which contain 1. Okay, so you tell me how many committees you can form generally without any condition. You have m teachers, right? And all these committees are 3 teacher committees. So how many 3 teacher committees we can form out of m members? Definitely MC3, isn't it? Remember it. So that MC3 is nothing but total committees. But in the problem they have mentioned that is x1 to xn. That means this n is nothing but MC3. The total number of committees are n, which is MC3. Note this point. Okay. The second point. How many committees contain teacher 1? You tell me how to form a committee where teacher 1 always present. We have seen this kind of problems in combinatorics. If you are not sure about combinatorics, please go through that combinatorics videos. Okay. Then to form a committee of 3 members where if teacher 1 is compulsory, then only vary 2 other things, isn't it? Try to understand. Just vary these 2 points, not 3, because 1 is compulsory. Then how many different ways you can vary these 2 points? These 2 points are coming from remaining m-1 teachers, isn't it? Out of m-1, any 2 you can select to form this kind of committee. So that's why the total number of committees where teacher 1 is compulsory is m-1 C2. We have seen this kind of problems in, combinatorics problems. Please go through them clearly. Now m-1 C2 is the answer, right, for f of 1. But our question is sigma I equal to 1 to m f of I. That means f of 1 plus f of 2 plus f of 3, so on, f of m, isn't it? Everything has the same value, that is m-1 C2, right? Plus m-1 C2, how many times? M times, because there are m such values. Now what is m-1 C2? We'll see. So if I expand m-1 C2, m-1 C2 is nothing but m-1 factorial by, m-1 minus 2, m-3 factorial into 2 factorial. If I simplify it, m-1 factorial can be written as m-3 factorial into m-2 m-1 by m-3 factorial into 2 factorial. You can cancel m-3 factorial. then you get m minus 1 into m minus 2 by 2, isn't it? Remember. So finally m minus 1 C2 is m minus 1 m minus 2 by 1 into 2. So you remember one shortcut, whenever you have NCR, then what you do is, for NCR shortcut is start at n, write r numbers in decreasing order, okay, and start at 1, write r numbers in increasing order. You automatically get the value of NCR. Start at n, write r numbers in decreasing order, start at 1 and write r numbers which are successive numbers in increasing order. You get the formula for NCR. So in the same way I can do here. Start at m minus 1. Of course I know the answer, but I am giving you this shortcut. M minus 1 C2 can be written as m minus 1 m minus 2. Write two numbers in decreasing order from m minus 1 and start at 1, write two numbers in increasing order. That's why m minus 1 m minus 2 by 1 into 2. It's done. In the same way, how many times? M times. So final answer is m into m minus 1 m minus 2 by 1 into 2. But if you see the options, no option matches with this m into m minus 1 m minus 2 by 1 into 2. So better what we do is we eliminate option C and option A, because they are not these things, correct? So m into m minus 1 m minus 2 by 1 into 2 cannot be simplified to 2m plus 1 or 3m. So probably your answer is in the terms of n's, right? Let's expand it. What is n? N is nothing but, according to our shortcut technique, start at m, mc3, right? mc3 equal to start at m, write three numbers in decreasing order, m into m minus 1 into m minus 2 by write three numbers in increasing order, m into m minus 1 m minus 2 by 1 into 2 into 3. Now see the answer. Our answer is m minus 1 m minus 2 into m by 2, isn't it? So m into m minus 1 m minus 2 by 2. Let's mark it. This is actually answer, right? Answer equal to 3 into n, correct? Answer n equal to answer by 3, then answer equal to 3 into n. So that's why the answer is option B. In that way I can solve this question. Let's one more question which is asked in 2005. Let f be to c and g a to b two functions. Okay, h is f o z. Given that h is an onto function, two things are given about h. H is a composite function which is f o z or f circle z, and it is onto function. We have to remember it. Now, which one of the following is true? We have to identify which of the following option is correct. Whatever information is given, let me write in a pictorial representation. Since our h is f circle g, right? Then let's begin with g. Okay, I am drawing g now. G is from A to B. Okay, so let's take some points. Okay, and in B also some points. This is G, and F is given as A to C, no, B to C, right? Okay, this is B to C. F is from B to C. Let me take some points. Now the question is, some more information is given, right? Let's take that also. H is an onto function. So H is, which is from A to C, onto. So for this problem, the best idea is, imagining, these functions as roots, right? So already I told you, this is, let's say, Telangana, this is Andhra, this is Maharashtra. Okay. Now Telangana cities are connected to Andhra cities through a function G, and Andhra cities are connected to Maharashtra through function F. Now H is what then? This H is connecting Telangana to Maharashtra but through Andhra, right? Okay, such H is onto. If this H is onto, so how can we interpret with roots and all? Then according to our idea, onto function means all the cities of Maharashtra are covered from Telangana using H function, right? That means H is nothing but two length roads, right? Two length roads. All these two length roads are covering every city of Maharashtra. Why? If some city is not covered, then definitely that is not onto, right? H is not onto. To become onto, H should cover every city of this Maharashtra through two length roads, because H is nothing but two length roads, we know that. Now if F is not onto, just we are seeing a possibility, let's say F is not onto. If F is not onto, then definitely I can say that some city is not covered from through roads of F, correct? From Andhra to Maharashtra, definitely the routes are not covering some city, let's say, then only this F will become non-onto, isn't it? Okay. If there is such city which is not covered from Andhra cities, then definitely how can you have a two length road which covers this city? Why should I cover this city? If you don't cover, H is not onto. To cover this city through two length roads, your this one length roads, definitely should support. That's why. So there should be one road like this. That means every city should be covered by this one length roads. Then automatically this F will become onto. So you can't say that F is not onto. That is compulsory. Now second thing, why G should be onto? That's the second question, right? We'll see whether G is onto or not. Think, conceptually, we have to start at Telangana, some cities, and we have to cover all the cities of Maharashtra through Andhra cities. But is it compulsory to cover every Andhra city? Why should I cover every Andhra city? Can we escape some Andhra cities? Let's try that. I'll show that pictorially. Yes, we can skip some Andhra cities. Example 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's say 4 is covering 8, 5 is covering 9, 6 is covering 10, 7 is also covering 10, 1 is covering 4, let's say 2 is covering 5, 3 is covering 6. Okay, now this is, still I am covering 8, 9, 10 from 1 to 3, isn't it? That's why, 1, 2, 3 to 8, 9, 10, which is H is on 2. I am satisfying the condition. For that, we know that F is also onto, correct? But what about G? G need not be onto. It is not compulsory to cover 7. Why should I cover 7? My goal is only covering 8, 9, 10. So without covering 7, I can cover 8, 9, 10 from 1 to 3. This is a counter example, right? So that's why 7 is not covered by G. That's why, G is not onto, right? Non-onto. That means what? It is not compulsory that G is onto. So G can be non-onto. We'll see the options now. G should be onto, F need not be onto, wrong. F and G should both be onto functions, wrong. So F should be onto, correct. G need not be onto, absolutely right. So option B is the right choice. In that way, if you have clear picture about the problem, like somehow if you interpret the problem clearly through some real world problems, then easily we can solve the problem. Here what I did is I understand this composite functions using two length roads. That's why my reasoning would become simple. Understand? Yeah, this question is asked in GATE 2001. Let's read it. A function f is given and which is from a to b, and e and f are subsets of that function, set A. They are subsets of domain. Now consider the following statements about images. One is f of e union f equal to f of e union f of f. Second one, f of e intersection f equal to f of e intersection f of f. Which of the following is true? Okay, we'll try to understand what is f of a set. I'll explain you with picture. Example, if you have 1, 2, 3, 4 here and ABC here. Let's say this is A, this is B, this is function A, F. We know that image of 1 is, let's say, A, image of 2 B, image of 3 C, let's say image of 4 C. In this picture, we say f of 1 is A, isn't it? We know image of single element so far, but in the question they have given image of a set. So image of a set is defined like this. Example, image of set 1 comma 2 is nothing but collection of all the images of 1 comma 2. That means collect image of 1, which is A, Okay, union, collect images of 2, that is B, then you get A comma B. Understand? I can say that it's all collection of images of set 1 2. Similarly, what is f of 3 comma 4, which is nothing but collect image of 3 C union image of 4 C, that will become C. You understand my point? Now this is about images of a set. Now consider statement number 1, that is f of E union F equal to f of E union f of F. Is it true is a question. Okay, so if you understand this functionality, then f of 1 comma 2 can be written as f of 1 union f of 2, isn't it? F of 1 union f of 2. Similarly, f of E union F can be written as f of E union f of F informally. So it seems like they are correct, but we'll try to prove it with a strong definition, like more rigorous way, otherwise with more concept. So what is f of E union F? For that, I interpret E comma F with some real world entities. Let's take E as Indians, all the Indians. F means software engineers. So try to interpret this. So F of any element is, let's say, from now onwards, example, F of Raju is, let's say, Rani. Then we interpret this like, whenever Raju's image is Rani, we interpret it like Raju's wife is Rani, so that your understanding will be more lively, so that you can easily understand the problem. Now set E is nothing but Indians, set F is nothing but software engineers. So E union F is nothing but set of Indians or software engineers. Okay, so whenever I write function f of Raju equal to Rani, then Raju's wife is Rani. That means image of Raju is Rani. Then in my interpretation it is wife. So here function is a wife function. Now what is the meaning of f of E union F then? So up to E union F is Indians are software engineers. F of E union F is nothing but wives of, right? F means wives, isn't it? Wives of Indians are software engineers. Let's write it. I can write that all the wives of Indians, a set called Indians are software engineers. So this is about f of E union F. Let's interpret f of E. F of E is nothing but wives of E means Indians, isn't it? Okay. And f of F is nothing but wives of software engineers. If I do union, what I get? I get wives of Indians union wives of software engineers. They will become wives of either Indian or software engineer. Here also you see wives of this union, E union F. E union F is Indian or software engineer. So Indian or software engineers wives. That means wives of again Indians or software engineers. Here also wives of Indians union wives of software engineers will become wives of Indians or software engineers, isn't it? So these two sets are equal, with respect to meaning wise, correct or not? So they look equal. Now we'll see second equation S2. Okay, try to interpret it. So what is f of E? F of E intersection F is dash equal to f of E intersection f of F. Is it true or not? We'll see. Let's interpret in the same way. F of E intersection F. E intersection F is nothing but where E is Indians, F is software engineers. Then E intersection F is nothing but common people. Who are common? Who are Indians and software engineers, isn't it? So I can say that E intersection F is Indians and software engineers. Such people's F means wives. We are applying wife function, correct? So you get wives of, if I apply image function, wives of these people. Which people? Indian software engineers, isn't it? Remember it. So finally it is wives of Indian software engineers. Let's come to this one, F of E. F of E is nothing but, wives of Indians, isn't it? Wives of Indians. Correct, because E is a set of Indians, f of E is nothing but wives of Indians. Similarly, it is wives of software engineers. If I do intersection, you get what? Wives of Indians, wives of software engineers, you get common wives, right? So there is a difference. Try to understand. Common wives. Let's read it again. Wives of a person who is Indian and software engineer. That kind of thing it is. Here it is. We are intersecting the wives. Try to understand the difference. We are intersecting the wives. Like wives of Indians and wives of software engineers. We are intersecting such wives. But here we are first intersecting the people, then whoever the common people you get, their wives. There is a fundamental difference between these two. Correct? See carefully. The common people like whoever Indian and software engineer, that people's wives are definitely different from Indians wives intersection in software engineer wives. We are taking wives common here, right? We are doing intersection for wives. Here we are not applying intersection for wives. We are applying intersection to the people who are Indian software engineers. Then after that we are getting the wives. Then you may get different answer. Example, I have a counter example for this. So why this is wrong is, let me take one assumption like Raju is an Indian, let's say. Okay. Now let me take one Chang. Chang is a Chinese person. Now Rani is a wife of these two people. Okay, Raju's wife is Rani, let's say, and Chang's wife is also Rani, let's say. In this scenario, still it's a function, right? Now let me take Raju is one set. Okay, now Chang is one set. Okay, Raju is an Indian, Chang is a software engineer, he is from China. Try to understand this example. Chang is from China, Raju is from Indian. So I am giving information. Raju Indian, Chang from China, and Raju is not a software engineer, but Chang is from software. So what happens is, if I apply E intersection F, so E intersection F is nothing but Indian software engineers. There is no Indian software engineer here. The reason, Raju is Indian but not software engineer. Chang is a software engineer but not Indian. In this case, intersection is what? E intersection F will become empty. There is no common person. Then if I apply for empty set wife function f of empty, that means wives of empty is empty. But if you come to this side, f of E. So what is f of E? Wives of Indians. Since Raju is Indian, wives of Indian will become, in this example, Rani, isn't it? Intersection. So we got Rani. Wives of all the software engineers in this example, there is only one software engineer who is Chang. The wife of Chang is Rani. Since she is a common wife, definitely she will come in the result. Understand? But why she is not coming in this result? Because she is not wife of a Indian software engineer. She is a wife of an Indian and at the same time a Chinese person. But she is not a wife of Indian software engineer. That's why she is not there in the left side, but she will be at right side. Why she is at right side? Because she is a wife of E, that means Indian. At the same time, she is a wife of software engineer. That's why she is at right side. Understand? That's why these two are different. So I can say that S2 is wrong statement, but statement 1 is definitely correct. Correct? So answer is only S1. So only S1 is correct. Let's see one more question which is asked in GATE 1997 paper. Let's read it. Let F be the set of 1-to-1 functions from set A, which is 1, 2, 3, so on n to the set 1, 2, 3, so on m. Okay. Where m greater than or equal to n greater than or equal to 1. We know that to have 1-to-1 functions, necessary condition, this set should be smaller than this set, otherwise equal. That's what the condition says. Now, how many functions are members of F? There are a lot of functions, isn't it? Out of them, how many are members of F? The member of property of that member is its 1-to-1 function. Then this question is indirectly asking how many 1-to-1 functions possible from this set to this set. Let me write it. 1, 2, 3, so on n here. and 1, 2, 3, so on, m here, isn't it? Then how many functions possible, one-to-one functions possible from this set to this set? We know the formula, that is, MPN, remember it. So MPN. This is question number one's answer. Let's take the second question. How many functions f in capital F, that means one-to-one functions, satisfy the property f of I equal to 1? That means some element I should map to 1. See, that's why he said for some I. Need not be for every element. Okay. So how many functions we can draw where one element, at least one element should map to 1? And however, more than one element cannot map to 1. That is also true in one-to-one function. Can we have mapping like this? Example, 2 is mapped to 1, 3 is mapped to 1. Impossible, right? That's a violation of one-to-one function. So though in the question he said some I can say exactly one I is possible. Now problem is reduced to one of the element in the functions, like in the domain, should map to 1, right? Let's show that picture here. This is your 1, 2, 3, so on, m. This is n, and this is 1, 2, 3, so on, m. So how many ways we can map one-to-one functions so that exactly one element should map to 1? So that means 1 should be mapped. So we do this problem like a task sequence. There are two tasks. One is, first I map 1 with one element. Okay. So we know that already I told you that multiple elements cannot map to 1. Only one element should map. But what is that? So that is task number 1. Task number 1, map 1 to some element, like some element 3 to 1 or 2 to 1, something. That is task number 1, mapping 1. Second task is, still function is not completely formed, isn't it? Just we map to 1. Then the remaining thing is, we have to map all these elements to all these elements, like 1 to whatever. So one element will be gone, remaining elements to be mapped to remaining elements, but we have to form one-to-one functions. If you do that, then overall function will be formed. Let's revise it. First, one element should map to 1. Take one element and map it. Then from the remaining elements, take the remaining elements here and map them in a one-to-one way. Then overall will become one-to-one. Isn't it so? Let's do it. T1 followed by T remaining task. You know what is remaining task? Let's remember it. Let's see what is T1. T1 is nothing but mapping one of the element in the domain to 1. How many ways we can do it? Since there are n elements, so one element we have to select to map it to 1. Then NC1 ways we can select one element, isn't it? That's why NC1. So what is the remaining job? The remaining job is, I can show the remaining job here. Okay, that remaining job is, so example, let's say 3 mapped to 1, in one instance. It may not be true every time. Assume that, let's say some element is already mapped to 1. Then how many other elements you have, like 1, 2, 4, 5 up to n, isn't it? Here you have 2, 3, so on, m minus 1. Now we have to take all these n minus 1 elements and we have to map to this m minus 1 elements in dash way, one-to-one way. Then only overall will become one-to-one. So how many one-to-one functions we can form from m minus 1 elements here and n minus 1 elements? We know the formula, that is MPN. That means second set size P first set size. So now effectively second set size is m minus 1, P first set size is n minus 1, isn't it? So m minus 1 P n minus 1 ways we can form remaining mappings. First one is NC1 to fix one element of this first set to 1, right? So according to product rule, if you do these two tasks, then only overall mapping will be done. So that's why according to product rule, when you have two subtasks to do overall task, then that subtask should be multiplied. That's why I am multiplying. So final answer is NC1 into m minus 1 P n minus 1. Okay.